Hi there, so here you see my active loop antenna, which I've done a couple of videos on, and it's basically 1.2 meter diameter aluminium loop with a box at the bottom with an amplifier in it, and that's fed with about getting on for nearly 200 feet of RG58, and it's been up there about 3 or 4 years and it works very well. But recently it was not working very well, and a lot of noise, and I thought, well, it's probably somebody around here has bought a new device which is interfering. Jumping to conclusions I was. But last week, when we had a nice day, I decided to investigate it further and had some very interesting results. I first suspected the loop might be faulty, so I disconnected it and took it in the workshop, and it tested fine. It was drawing its normal 140 milliamps at 12 volts. So I went up to the top of the garden and I measured the connector, because I'm feeding 13.8 volts at one end, and by the time the loop's connected, that and drawing 140 milliamps, and the coax measures 10 ohms resistance over that total length, I was getting normally with the loop connected 12 volts, which is what it's designed to run on. But with the loop disconnected and taking a high impedance multimeter and measuring the plug across the plug, I was only getting 12 volts, which is not good when you think that the impedance of the meter is 10 meg ohms and there's absolutely no load on the end of that cable. So I suspected a break or some damage to the cable. So that began a saga which I'd not expected, and expected to do the whole job in an hour, fix the fault in an hour. 3 hours later I did get it working again, but I had to drag all the cable out, which goes all the way up the side of the garden, through along the one fence, around various bushes, and of course it all got entwined with ivy. It was a hell of a job pulling the cable out. But eventually I got the cable out and I found a very small cut in it. It wasn't cut through completely, but then stripping it back, the copper braid had completely dissolved. There was no sign of any braid whatsoever, and it was about all the way up, about 2 feet on each side. It had corroded away to nothing. So I think I'll continue this in the workshop. So to continue my story, I found this break in the cable, and I did a temporary repair by just soldering the inner and the outer together and wrapping it all up with tape. But don't like bodges like that, really. And I got the loop working again, and it's working at the moment with that soldered joint wrapped up with tape. But you know, sooner or later the water's probably going to get in, and I haven't got any more decent quality N-type connectors to do a proper joint. And anyway, the cable's now a bit shorter than it was, and it doesn't really reach right round where it used to reach, which is untidy. So I went on to eBay to see if I could get some more RG58 at a reasonable price, and I thought I'd go for 100 meters, because I know I need more than 50 meters, and might as well buy 100 meters. It's probably about 60 meters I need, 180, 200 feet roughly. So eBay, I looked on eBay and I saw one seller selling 100 metres for 62 pounds, I think £10 postage. Bit expensive, I thought, and I continued looking. Then I found some for £27, free delivery. I thought, interesting. Well, I thought, you get what you pay for. It's probably not going to be that great in quality, but you know, I'm only using it on low frequency. It's not like I'm going to stick VHF up it. I'm only really interested in using it on 160 metres, 80 metres, amateur radio bands, so like 3.8 megahertz maximum, occasionally a bit higher. So I thought, yeah, I'll take a chance and I'll buy this cable, and it arrived 2 days later, and I'll just show you that. So this is what I bought. This is the roll of 100 metres of RG58, and it even says RG58 on it somewhere. Yeah, don't know if you can read that, RG58/U. So, but if you have a close look at what we've got here, the actual screen on it is pretty good, but the centre conductor is really looking pretty awful. It's so thin, it's well under a millimetre, probably half a millimetre, and conveniently they've left one end hanging out from the centre, and so I can get my meter on it to measure it. So what I'm going to do is I'll measure first of all from the screen to the screen resistance. That's my main concern with this stuff, is how poor it's going to be in resistance. And I got 11 ohms, which is reasonable, over 100 metres. So, but if I go for the centre conductor, then you get a real shock. It's 64 ohms. That's unbelievably awful. Add that onto the 11 ohms, that comes to 76 ohms, I think. Yeah, 76 ohms. That's what I measured anyway when I shorted one end and then measured the other end. So that is pretty bloody awful as far as resistance goes. If I go down to my bit of paper here, we will see that on my old piece, which is roughly 60 metres, I've got a total resistance, inner and outer combined, of 10 ohms, which is certainly reasonable. And on the new, I'm getting 76 ohms over 100 metres. Okay, I ain't going to be using 100 metres, but even on 60 metres, if you do all the calculations, you get 46 ohms. That's a hell of a big difference between that and 10 ohms that I've been getting before. And the main problem, of course, when I just correct my spelling in there, but anyway, the main problem, of course, is going to be that over the old cable I was feeding in 13.8 volts at one end and drawing 140 milliamps in the loop amplifier box and getting 12 volts roughly, which is fine because the loop's designed to run on 12 volts, so I was dropping 1.8 volts. That's fine. But if you do all the calculations with the new cable, I'm only going to end up with 6 volts, which is absolutely crap. So that would be completely hopeless. So the only way to get around this problem is to increase the voltage. And to do that, I did the calculations, and I would need 20 volts at the radio end to produce 12 volts at the loop end with 140 milliamp load, which is okay. I in fact did find earlier one of those little plug-in power supplies which said it was producing 19 volts, Whether it would produce that on load, I don't know, but I could probably get around that. But I'm more concerned now about the actual attenuation due to that extra resistance. So I'll just have a look at it on the spectrum analyzer with tracking generator and check the attenuation. So I've got my spectrum analyzer set up, and I'm sweeping from 0 Hertz to 30 megahertz, and I'm feeding the output of the tracking generator back into the input using some fairly thin cables with crop clips on, and at these frequencies that is not a problem. And I just need to normalize this to get rid of the cable loss before I do the measurements. So I do normalize and then marker. I basically got 0 reference point, 0 dB reference, with just these cables connected like this. I don't know why it's going to overload, but anyway, never mind, shut up. Anyway, I'm now going to connect up to my piece of coax, 100 meters of coax. Okay, there we are, that's connected up, and just by random in the middle of the screen we've got 15 megahertz on a loss of 24 dB. Well, that's pretty horrendous, but if I go to 3.5 megahertz I'm getting 19 dB a loss, and that is just appalling. True, I won't be using the full 100 meters, but it's still going to be somewhere, you know, a hell of a lot of loss. Yeah, it's going to be over 10 dB of loss, I'm sure. And even if I go down in frequency to 1.8 megahertz, I'm still getting 15 dB of loss. And you can go lower and lower and it's still awful all the way down. 800 kilohertz, 10 dB. And most of that loss is going to be the resistive loss. The dielectric loss isn't going to be that high at these sort of frequencies. So it looks fairly hopeless, this cable, but I think the only thing I can try and do with it is roll it all out, not all of it, but run it from the radio room through the window temporarily, and uncoil roughly the right amount with a bit extra, and then put a plug on one end that plugs into the loop, and do a test, a comparison test between the old damaged cable and the new cable. But that is really quite hard to do on these frequencies, because signals on shortwave HF are varying constantly, minute by minute, second by second. So you really need a local source of signal that's not going to be affected by propagation. So I found a way around that one, which I think will work quite well. So what I'm going to do is I'm going to use my signal generator, probably set it for 3.5 megahertz, something like that. And I've already done this test earlier and it works quite well. And I'm going to use this thing over here, which I was given a few months ago. I don't know if you can see what it says, but it calls itself a test loop. And having looked in the box, it's got several turns of wire going around this inside of this aluminium loop. And I guess it was probably used as a field strength monitoring antenna for maybe transmitters or something. But I've discovered if you shove 10 milliwatts up it on 3.5 megahertz, I get an S9 signal on my loop, and it's a consistent signal which is not going to be affected by propagation. My only slight concerns are that you could, in theory, get some signal getting through this screen of the coax, which is not far away, just outside this workshop actually, but probably not a problem. I hope it's not a problem anyway. When I tried it earlier, I turned it round and it did seem to work quite well, because this is now facing in the same plane as the loop antenna. So you could get a definite null if you put it this way around, for instance. So when we get some decent weather, which it isn't at the moment, it's been really crap. High winds yesterday, not much better today, and it's been raining today, but I think we're going to get better weather later in the week. It will probably not take me long to do the actual test, so that will be the next part of this. So, the conclusion of the coax saga. I did a bit of research on the internet, and depending on which variety of RG58 you have, the highest loss figures at 3.5 megahertz was 3.5 dB at I think 3.5 megahertz. Now I was measuring about 18 or 19 dB, which just shows you how awful that coax was. But anyway, I decided, and I didn't video it because I thought it would be too tedious, I decided to run a 60 metre length up the garden, roughly 60 metres anyway, certainly enough to go all the way up in one piece around the mulberry bush and various other bushes and trees along the side of the fence out the way. And I connected it all up, and I used a plug-in power supply, you know, one of those little black things that plugs in the wall, that was producing 19 volts off load. And of course, as soon as I connected it up, the voltage dropped to 17 volts, which was probably to be expected. But anyway, then I went up the garden and measured the voltage at the loop, and it was only 9 volts. So that was a bit of a setback to start with. And I couldn't be bothered to take a variable power supply upstairs and try it on 20 volts or whatever voltage would give me 12. But I don't honestly think it would have made a lot of difference. I did a test transmission on 3.5 megahertz, and with S9 on the old cable, the signal was down to S7 on the new cable. So that's a good 2 S points down at 3.5 megahertz. And as occasionally I would use it at higher frequencies, it would be even worse as you go up in frequency. So I think the conclusion of all this is that cable is virtually useless. I wouldn't even want to use it for more than a couple of meters with the losses it's got, and I would certainly never use it at VHF. So it's basically scrap. And the moral of the story is, don't buy cheap coax, and I should have known better. So there you are, I've wasted £27 on a load of crap coax. But we live and learn. So, bye for now.